Thank you, Shia, and thank you, Philip Clayton. It's a real pleasure to be here back at Harvard once again, and I see many old friends as well as some new ones here. I'm very appreciative that you turned out on this beautiful summer day and didn't take advantage of the weather to do something else here in the square. These beautiful surroundings with beautiful blooming trees. Perhaps the hardest task for human minds to thematize reality. I say perhaps because some moods make it seem easy to thematize reality. Life is cruel, life is unfair, just a bowl of cherries. The analysis mocks our moods. Their volatility, the volatility of those moods, gives a bad name to metaphysics. There are, of course, concerted opinions, products, or promoters of a preconceived outlook. Christians often speak in code or shorthand, making words like plan or purpose reference only to a particular narrative read in a particular way. The main lesson of experience, Alvin Plantinga writes, is the inklings it affords of God's plan for dealing with our fall into sin. That's a somber message, perhaps, a bit precipitate, as any innocent answer to a compound question might seem. Are we fallen? And is that the salient fact about the cosmos, infecting even our reasoning, perhaps making it unreliable, or skewing the laws of physics so that entropy, say, results from atoms' fall? There are moods that make it seem that all is lost and every effort futile, every triumph a delusion. Skepticism and cynicism answer to such moods. So does the impulse to throw ourselves into the arms of fate, or the state, or some deus ex machina, a mahdi, or a cause. So does the Buddhist strategy of letting go, foreclosing desire as the willing accomplice of suffering, with the same sort of logic as Paul's reasoning that made law and morals authors of sin rather than its enemies or remedies. Even suicide from the despondent posture may seem over-optimistic, a false promise of control purchased at the price of self-negation. Conclusions drawn in all these cases may reflect our emotions, but not any careful study. Despond derives its edge and energy less from global wisdom than from the seeming sagacity of a defensive tactic, of preparing for the worst and hoping not to be or seem naive about life's pitfalls or insensitive to them. We don't want to kid ourselves or look like Panglosses or Pollyannas. Still, religions do try to thematize experience. Monotheism, in particular, looks for global themes and not fragmentary facets of experience, but real properties of the world. Thematizing is an impulse that religions have in common, and the urge to global thematizing is a shared trait of monotheisms. The underlying premise feeding the monotheistic idea and nourished in turn by the kind of religious experience that monotheism fosters is that things make sense. Sciences, like religions, seek understanding, and they too may seek global understanding. Consilience of evidence is their strength. That means not closeting knowledge gleaned in one exploration from what we find or stumble onto in another. If there's a difference of focus between science and religion, it lies in the fact that our natural sciences seek causal understanding about the world we can see and touch, and the things in it that we can gauge and measure, and tease out from one another, not just conceptually, but experientially, and thus reliably relate to one another, ideally by type and mathematically. Often the focus is on things we can control. For although science is never just the handmaid of technology, it does yield uses. So it's no coincidence that Bacon, who saw the naturalist as interrogating nature and laid the groundwork for that great revolution that carried science beyond Aristotle's qualitative, anti-Democritean, non-mathematical interests, seeing the relevance of the quantitative and laying the foundations for the rise of the controlled experiment and for statistical testing of our findings, that Bacon also said that knowledge is power. Religion, too, seeks knowledge, and again, power is a byproduct, neither unlooked for nor reliably benign. But here the quest probes beyond the measured interactions. There's still talk of causes, but ultimate causality is the quarry, beyond the immediate structures and patterns of the scientific motherlode. The vein religions want to mine opens up onto realms of value. Monotheism seeks an ultimate causality in ultimate goodness. The driving premise is now moral. Violence, pace the pagans, is not power, for it lacks the coherence that would give it efficacy, and all that is merely bounded falls short of the ultimacy that a monotheist deems worthy of worship. So death, despite the Heideggerians, is not an answer, and sin, despite many a pious penitential, is not the ultimate. Christian philosophers may mourn man's fallen state, but in the end they turn to grace. Kohelet may rail at the vanity of all things under the sun, but he finds respite from his restlessness in a homely, if never simple, piety. And the Song of Songs will breathe the passion of young love, but it needs no help from allegories long forced upon its text to find transcendence in that love's consummation. Intellectually, the power of science comes from comprehension, and the comprehensiveness of science finds its leverage and pays its price in the coin of abstraction. One can't devise a theory of everything without omitting almost everything. Just as a painter brilliantly frames a space that vision can enter alone, although one cannot walk there, and just as a composer makes a world where tones dance and the inner landscape they create, or a novelist engages us with the fate and discoveries, hurts and losses of imaginary people, and releases words to us that expand our experience and plant new thoughts in our minds. So the scientist abstracts from nature's thick reality to distill a pure residue from the mingled factuality of things, crystallizing an account, naming and distinguishing, quantifying and relating causes in the teeming muddle of the whole, the tangled bank, as Darwin called it, making visible an order in the seeming chaos, a confusion born not of the mind, but of the profusion of causes, extraneous to the one clear ray of light that a keen theory will extract. Religion, too, gets its power from comprehension, not the specious power of magic or superstition, or the coercive power of dogma, but the peace-giving power of insight. And, as in science, comprehension is not quite the same as comprehensiveness, and control can be illusory or vicious. Our greatest strength may prove reflexive, the power to control the self, as the Mishnah teaches, not to dominate brutally or subtly by twisting others' wills or deflecting their desires or trying to blinker their minds, but the power to set oneself in tune with nature's deeper themes, including moral themes like interdependence and the need to honor claims in proportion to their worth, to respect all beings and accord dignity to every person. Here, comprehension becomes not just critical, but vital. A Herbert Spencer might see the emergence of identity as the underlying law of the cosmos, but his misprision of that idea warns us of how vital it is to know just what identity and self-affirmation can mean, lest we wrap ourselves, as Carl Sandburg put it, in our own revolving mirrors, and losing sight of others, lose sight of ourselves. We do need to know ourselves as the Delphic oracle commanded, but that demand can demand a bit of digging. To archaic Greek piety, self-knowledge meant recognition of our own mortality. To Plato's Socrates, it meant discovering the God within. If Socrates was right about that, his gloss demands we ask what counts as a God. The monotheist finds no mere creature worthy of such deference. So the rabbis find the whole of God's law summed up in the rejection of idolatry. But that insight gets its moral valence when lived out in acts of loving kindness. Only goodness, beauty, and truth are holy, values not in conflict as in polytheism, but fused in God, the ultimate source of all value. If we ask how autonomy authentically affirms itself, the biblical and rabbinic answer is that we seek and reach that goal by emulation of God's generosity and compassion. When we genuinely know who and what we are, Spinoza taught, piety and humanity become synonymous. As hinted by the Hebrew word chesed, our task is love, above all, of our fellow human beings, biblically said to have been formed in God's own image. The mirror that captures so intimate and telling a vision of the self is the full cosmos, in which we see ourselves as members, workers in a common enterprise where personal growth, intellectual and moral, spiritual and artistic, is both the means and the outcome of loving service of the good, hand in hand with others. So here too, as in the sciences, our study of nature is of the essence, but now we listen with an ear cocked to themes that we can catch behind and beneath the steady hum of the natural continuum. The themes we listen for are those of love and grace, for it is in the generosity of hope, creativity, and discovery that monotheists believe they sense nature's heartbeat, signals of a life deeper than our individual lives, leading theists to declare that nature has a creator. In the coalescence of things, the integration of selves, the emergence of life and understanding from seemingly unpromising materials of matter and chance, monotheists see marks of transcendence, even in a simple and familiar act like the giving of a gift, sharing of a smile, acts of generosity, justice, or compassion, acts of love from a partner toward a child, toward humanity, or nature at large. We see emblems of a higher love, relative goodness, even the goodness that we mourn when it is lost, and fear for when it is threatened, seems to bespeak a higher beauty and goodness beyond what we see more immediately in nature. A source not merely vast but infinite, not merely powerful but wise, not merely beautiful but generous, an ultimate source of beauty, truth, and goodness in what is beauty and truth and goodness itself. So much for introduction. I'm going to talk about two issues now. The first one has to do with the Big Bang. The second one has to do with evolution. And both of them are connected with what has become a very contentious word, creation. I mentioned creation. Is it kosher to talk about creation today? Or is that word to be given up to backwoods primitives, as the word sublime was largely given up sometime in the early 20th century to urban sophisticates who wanted a word with special oomph to describe their friend's new frock or the latest cocktail? I think the word creation still has a lot of kick left in it. Even sublime might be due for a revival, as virtue was toward the end of the last century, thanks to Alistair McIntyre. But what about creation? Ever since Parmenides founded metaphysics, relying on the idea that the logic of identity makes change impossible and radical change absurd, creation was under threat. Atomists urged that nothing comes from nothing. Neoplatonists joined forces with Aristotelians in holding that the ultimate constituents of reality, the species of things, living species especially, not to mention the heavenly bodies and the cosmos itself, do not change in any essential way and cannot have an origin or a demise. The claim, anchored in logic, so it seemed, but also in reasoning about the nature of the divine, was ancestral to the idea of the conservation of matter. But scriptural monotheists balked. By making the world and what the Peripatetics called its principal parts eternal, the notion of the world's eternity seemed to find the wrong kind of ultimacy in the wrong kind of ultimates. John Philoponus, the great Christian cosmologist of the 6th century, argued brilliantly against eternalism, finding evidence of process and thus of finite duration even in the colors of the stars. Shmuel Sambursky points out that Philoponus was the founder of astrospectroscopy. Yeah, you know that. But science, for the most part, seemed to take the other side. Naturalists feared that nature would lose its stability if species could change, and pagan philosophers insisted that the heavens and the cosmos, too, must be eternal, since they, and not just their causes, were divine. Besides, it seemed irrational for divine causality to be hemmed in by any finite duration. Everything that can exist, does exist, and must exist, the Neoplatonists argued. Only so could one see how an infinite God would express himself in a temporal world, and only so could Aristotelian science meet its mission of showing why all that is must be as it is. Scientific rationality joined its voice to pagan piety. Scriptural monotheists looked unscientific, and their God capricious. The Muslim theologian Al-Ghazali might argue that it made no sense to call oneself a theist if one also held the world to be eternal, for a necessary and eternal world seemed to need no God. But Neoplatonists argued that change demands potential, and potential needs matter. So time and the cosmos must be eternal. Maimonides would counter that one cannot judge such questions by projecting onto the world's formative stages our present understanding of time, matter, motion, and potentiality. Like Ghazali, he would insist that contingency is real, and the world as it is does not exhaust the realm of possibility. Couldn't the spheres have been larger or smaller? Ghazali asked. By the breadth of a fly's wing, couldn't the spheres have turned in the opposite sense? Maimonides asked. Couldn't the star's array have been different than it is? Surely, both men urged, one can't explain all of nature by an appeal to the eternal essences of things. Experience, too, is necessary. Opium, Al-Ghazali complained, is supposed to induce sleep because it's cold. But earth and water are the cold elements on the philosophical account that passed as science in those days. And pounds of earth and water, he said, have no such effect as a dram of opium. One might suppose, Ghazali argues, that something as tiny as a grain of wheat could hardly devour a town and then consume itself. But that's just what fire does. Maimonides chose a different illustration to support his empiricism against necessity and a priorism, aligned against creation. A bright lad, he said, who had never seen a female, would find it absurd to be told the natural facts about his own birth. Surely, he would reason, my body needs air and food. I need to move about and eliminate bodily wastes. How could I have lived for 9 months in a close sack inside another's body? Projecting the familiar conditions of his present life onto his own developmental past, he would reject the story of his birth. Just so, Maimonides argues, philosophers reject the world's creation because it breaches what they take to be the settled laws of nature. Maimonides upholds such laws and ardently defends them. They're essential to his work as a physician and to his understanding of astronomy and engineering. But his notion that familiar principles have not always been just as we know them seemed unscientific. Even in Spinoza, that bias persists. In some quarters, it still does, despite the vindication by Galileo, Copernicus, Newton of Philoponus' efforts to naturalize the celestial realm. For even today, die-hard eternalists like Adolf Grünbaum, I mention only one name, but there are others, hold fast to the world's eternity, motivated perhaps by their antipathy for religion. When I was in college here at Oxford, Fred Hoyle's steady-state theory, Here, did I say Oxford? Text says Harvard. All right. When I was in college here at Harvard, thank you, Shia. Fred Hoyle's steady-state theory still seemed a near even money bet with the rival idea of the Big Bang. Astronomers like Fowler and other steady-state cosmologists were uncomfortable with the notion of an initial singularity, even though the redshift forced them to posit continuous creation, to explain new matter, to posit new matter to explain the evidence for an expanding universe. But in the relatively few years since my graduation, the Big Bang has been strongly vindicated, and eternalism knocked back on its heels. Not conclusively, of course. There's always the possibility of infinite alternating expansions and contractions of the cosmos, but the Maimonidean thought has been vindicated. The rules of physics did work rather differently, as we see it now, when the world was new. And the notion that the cosmos had an origin has gained powerful confirmation. This was the thought that scriptural monotheists long assumed would deliver them home free to the further claim that the world had a creator. Would that things were that simple. Having good reason now to believe that the universe had an origin, cosmologists stand divided in the same lines that classically divided theists from non-theists. George Nachnikian writes, rendered in the terminology of contemporary analytic philosophy, Aquinas' and Duns Scotus' answer to why the Big Bang universe exists is as follows. God contemplates logically possible worlds. He decides to realize the logically possible Big Bang universe. Without that decision, the Big Bang universe would not exist. The picture these words paint is perhaps a bit too vivid, like the cartoons for a medieval tapestry or the figures in a stained glass window. Is that what Nachnikian means to suggest by mimicking the language of analytic philosophers? Not every theist will warm to the image of a temporal God toying with varied ways of creating and the null option of just not creating at all. But the idea that the world's existence is contingent upon God's act and grace does capture something of what theists have looked for in the idea of creation, whether that idea is confided to the poetry of Genesis, or Plato's likely story in the Timaeus, or Avicenna's emanationism, or Henri Bergson's creative evolution. Yet, even so modest a claim as Nachnikian's finds its allies and detractors. Theists like William Lane Craig defend a theistic Big Bang. Quentin Smith offers an atheistic reading of the same phenomena. Following the same Hartle-Hawking quantum cosmology that Nachnikian takes as his springboard, Smith calculates the probability of the initial state of Big Bang cosmos, derivable in principle, as he puts it, from the wave function used in that model on the order of 99%. In other words, the world pretty much had to exist. Hawking argues in stronger terms. The idea that space and time may form a closed surface without a boundary also has profound implications, he writes, for the role of God in the affairs of the universe. If the universe is really self-contained, having no boundary or edge, it would have neither beginning nor end. It would simply be. What place then, he asks, for a creator? That rhetorical question seems to presume a physical God whose interventions, as it were, are made from offstage in the wings, the edges or boundaries of Hawking's closed time-space surface. Nachnikian has charged as much, but Smith vehemently rejects the charge. This is not true. Both in my writings and in Hawking's writings, we have explicitly asserted many times in my case that a divine creator is not a physical cause. The God we are talking about is not Zeus, but a standard deity of perfect being theology. Still, it's hard to see if Hawking's argument is valid, how it avoids collapse into a tautology. If Hawking's time-space continuum is sealed tight enough to keep God out, isn't it assumed that God's act will be physical? And if the notion is that there's enough in Hawking's model to obviate all reference to God's act, how does the argument, so like Laplace's nous n'avons pas besoin de cette hypothèse, avoid the circularity of simply presuming that physical causes are the only sort to be entertained? Quantum cosmology, Nachnikian argues, cannot imply the falsity of theism, since the two address quite different orders of causes. And here, Smith seems a bit unfair to Hawking. For Hawking wrote in 1984, this is Hawking now, I thought I had left the question of the existence of a supreme being completely open in my article. It would be perfectly consistent with all we know to say that there was a being who was responsible for the laws of physics. However, I think it would be misleading to call such a being God, because this term is normally understood to have personal connotations which are not present in the laws of physics. That's a very typical move, by the way, in people who want to back away. They assume that everyone who is religious is what I was early calling backwoodsman. Real religion, authentic religion, must be very, very primitive. So if you have a more sophisticated idea of God, obviously you're not an authentically pious person. But Smith insists that the Hartle-Hawking cosmology logically entails that God does not exist. So he's parting company with Hawking himself there. Challenged to explain an event of pretty major consequence that now seems to be begging for a cause, Smith bobs and weaves. Space-time did not simply begin causelessly, he says. It is, in fact, contingent and originate, dependent on, would you believe, a necessary cause, just as Alvin Plantinga urged. That cause Smith is ready to allow must be singular in its creative work, indeed simple and transcendent, if only in the sense that it is not part of the cosmos it is meant to explain. But it is not God. Oh no. It is a spatially zero-dimensional point. This written in nice black type in fancy-looking journals. It is a zero-dimensional point, identical, in fact, but not of necessity, with the Big Bang singularity from which our maximal space-time, the Friedman universe, exploded and began to expand. So, faced with the formidable logic of the analytic philosopher Alvin Plantinga, Smith has allowed exactly the logic of Plantinga's argument, but said what it entails is not God. It's this singularity of this instantaneous point. Smith here drops his earlier view that he says treated the Big Bang singularity as a temporal being, as metaphysically now contingent and dependent upon space-time, and thus lacking aseity as contingently uncaused, and thus immanent rather than transcendent. His atheism remains. The new tack, now more redolent of the atomism of the medieval Islamic occasionalists of the Kalam than of the insouciance of Laplace, is motivated pretty plainly by the sense that it might be unseemly for a cosmologist, after science has explained so many things, to leave the universe itself unexplained. For Smith's dimensionless point is a posit, answering not to some new evidentiary datum, but by his own avowal to objections of the sort that Plantinga raises. There's no knockdown, drag-out case for theism. Sajja Gaon, a little over 1,000 years ago, explained why. The first premise of theism, the first premise of any discourse about theology, he said, is that whoever embarks on it is pursuing that cannot be seen with the eyes or apprehended by any of the senses. Rather, what one hopes for is to reach the truth through rational inference. The question is how things came to be. So what one is seeking is in principle abstruse, subtle, imperceptible. That is why one hopes to capture it in thought. But since what is sought is such, it is as such that its seeker must set out to find it. And if he finds it to be of the form he sought it in, he should not disclaim it or try to shift it to some other form. Elegant piece of reasoning by Sajja from the 10th century. The point being, well, you've all encountered sophomoric people who will say, okay, you're going to explain everything in terms of God, so how do you explain God? And they're looking for a kind of reductionism, and what they mean by an explanation there would be reducing God to terms, coming back to something physical, and that is what Sajja is warning against. You're looking for something that would transcend the system it's meant to explain, otherwise it can't have the function of explaining in the sense that the monotheist is looking for. It's part of the human condition that we live in uncertainty about God, Sajja reasons. Clearly, the redshift has transformed our world, and an origin is no longer the fairy tale it was once taken for, where dimensionless atoms were once posited ad hoc by occasionalist theologians in a costly effort to make creation an ever-ongoing, if unseen, act of God. The tables are now turned, and a dimensionless point becomes the ad hoc posit in an effort to block recourse to God. The motives in the dispute remain much as they were, even if unstated. Atheists and theists argue with vehemence, not because they differ over some uncaused atom. They differ over the nature of our world and the worth and meaning of our lives. That is, they differ over values. So an argument like Quentin Smith's is just as inconclusive as the Kalam argument that it innocently mirrors and mimics. Creation isn't meant to explain just why there was an initial singularity. It isn't even meant to explain just why anything exists at all. Creation as a scriptural hypothesis makes sense only if one thinks that being is good, that life is especially good, that human life and consciousness are so manifestly good as to warrant an appeal not just to a cause that transcends time, but to a being of infinite perfection, whose transcendent goodness is expressed in finite beings, peeking out at us, as it were, not from the wings of time and space, but from within. In planning the education of young people in the virtual republic that Socrates constructs, Plato has his brother Glaucon suggesting that the guardians of the Republic should study astronomy. And Socrates laughs at the idea, which he finds kind of half-baked. He says, "Why do you think they should study astronomy?" And Glaucon says, "Well, because it sets the mind on higher things." And Socrates retorts, as if anyone with a cocked head might learn something by staring at the decorations on the ceiling. If it's just a matter of looking at the sky, Socrates says, one might better say that the soul is looking down. But seeing the mathematical beauty of the heavenly motions might indeed draw the soul toward the transcendent. Isaiah, in a similar sense, urges us to look to the heavens and consider their creator. When he says, "Lift up your eyes and look about," his thought rises sharply from the dismissive reductionism taken for granted by many a mechanist, a reductionism that traps many a philosopher who apes the analytic idiom in hopes of stealing the cachet of science. What we're looking for when we search for the transcendent is not likely to be pictured in a cartoon, but it might be seen in beauty, whether in the stars or in the microscope or in the elegant, unseen pattern that lies behind the manifold that we encounter, the pattern perhaps captured in an equation or glimpsed in the smile on a human face. Such images press us to the boundaries of our finitude and ask us to look deeper. Let me turn from cosmology in general to evolution in particular. Darwinists are sometimes charged with holding a theory that is unfalsifiable and thus empty, covering all the bases and allowing for no possible evidence against their claims. But Darwin himself specified that his system would absolutely break down if it could be shown that there was any complex organ that could not have been formed by numerous, successive, slight modifications. Evolution, he insisted, must move by tiny baby steps. Natura non facit saltum. Nature doesn't go by jumps and leaps. That stipulation opens the door to a widely repeated objection raised today under the banner of intelligent design. Michael Behe argues that living systems are irreducibly complex. Removing any part cripples the system. If the parts alone have no adaptive value, the system cannot be produced directly by slight successive modifications, the subassemblies being non-functional. Darwin was well aware of the problem. C.H. Waddington called it the problem of unbridgeable gaps. His aim was to bolster Darwinism to meet the challenge, but today's ID critics aim to find natural selection inadequate. Unlike the proponents of creation science, they're not biblical inerrantists. They do not rest their case on scriptural authority. They do not posit a worldwide flood to muddle up the geological evidence or the fossils. They do not insist on a young earth or hold their intelligent designer to a strict 6-day work week. Many are reticent to refer directly to a deity at all, lest their view be deemed religious and thus barred from the public school curricula. They like to cite biological evidence, especially at the subcellular level. Take the cilium, the organelle that enables sperm to swim. Hundreds of cilia beat rhythmically in each cell of a respiratory lining, clearing fluid from the air ducts. Behe details the anatomy. Each cilium is a bundle of fibers, a pair of microtubules made up in turn of 13 strands of protein, tubulin, the pair ringed by 9 more microtubules, each composed of fused 13-strand and 10-strand members. The electric charges on the protein chains line them up, and lateral connections link the central pair to the 9 peripheral tubules and those to each other. There's an Abi bulb capping the strand so that motor proteins, called dynein, project laterally from each peripheral microtubule, and experimental work with proteases, breaking up these proteins into their components, shows that the cilia beat when the parallel microtubules slide past one another as the dynein connectors move up and down their length. The knobs prevent overshooting, lest the mechanism unravel. The cilia, the microtubules, the dynein motor, the connectors, none of these, Behe argues, functions by itself. So, how could the system arise piecemeal? Just as a mouse, this is Behe's words now, just as a mousetrap does not work unless all its constituent parts are present, ciliary motion simply does not exist in the absence of microtubules, connectors, and motors. Likewise, the flagellum. The whip-like filament anchored in the cell membrane of certain bacteria actually rotates, turned by a ring-like motor at its base, powered by a flow of acid through the bacterial membrane. Behe sees no way for natural selection to assemble these components. Thousands of papers, he says, have been published on the structure, yet no scientist has ever published a model to account for the gradual evolution of this extraordinary molecular machine. The system, he argues, bespeaks a pre-existing plan. Similar objections were lodged against Darwin even in his own time. Adam Sedgwick cited the mutual adaptation of parts in an organism and drew the familiar inference, I see all around me a design and purpose. The argument that he puts forward echoes Paley, and old versions run back to Plato and the Stoic claim that if a sailing fleet or an army deployed in the field must have a central command, all the more so does the budding of a vine or the harmony of the cosmos. Galen, the great physician, body physician of Marcus Aurelius in the 2nd century, took up the Stoic thesis. Organs, he said, would be useless without coordination and the right physiological and behavioral capabilities. Wings would be no use if birds could not use them and learn and teach their young to fly. Darwin responds. Darwin's words now. If numerous gradations from a simple and imperfect eye to one complex and perfect can be shown to exist, each grade being useful to its possessor, the difficulty of believing that a perfect and complex eye could be formed by natural selection, though insuperable by our imagination, should not be considered subversive of our theory. Light-sensitive nerves and primitive eye spots allow Darwin to model hypothetical precursors of the complex and perfect mammalian eye. The so-called flying lemur shows how, say, bats might have evolved wings from structures earlier used for gliding and parachuting through the trees. Wings, Darwin notes, are fins and forelegs to the penguin, sails to an ostrich, flappers to a loggerhead duck. We can't assume that precursor parts had no useful function. Mammalian lungs are swim bladders in fish. Homology is not analogy. The eye is a classic favorite case in arguments from design, but Behe updates the old arguments with systems theory and invokes biochemistry and cytology to push his brief. Earlier investigators, he urges, might have thought that they would find simplicity within the cell, but biochemists and cytology find immense complexity. Hence, Behe's title for his book, Darwin's Black Box. Electron microscopy and biochemical analysis reveal no simple building blocks, but systems within systems. Unlike the ancient Stoics or the more modern vitalists, Behe is unfazed by the thought that organisms are nested series of mechanical systems. He's delighted to call the cell a machine and to call living beings machines as well. But he still finds mystery in mechanism, especially in minute organic subsystems. He lovingly details the cascade of events needed for blood to clot, calling such mechanisms Rube Goldberg machines, intricate feedback loops which regulate the life processes and demand coordination of the separate pieces, he says, each acting in turn, one after the other, to accomplish the function. If the removal of any one of these parts causes the system to cease functioning, then he asks, if no step has value by itself, how could the cogs and levers active at each stage possibly have evolved by natural selection? Questions of this sort pinpoint both the strength and the weakness of the ID argument. It's a classic reductio ad ignorantiam with an added fillip. Organic complexity is not just hard to explain. Its intricacies demand not just a rare run of the dice, but they snag natural selection on a kink, a catch-22. You can't get A without B, C, and D all the way to N, but the whole series depends in turn on A. None of the parts or phases would exist or function without the rest, at least No one seems able to say how. That, says Behe, throws an enormous monkey wrench into Darwin's gradualism. Behe claims to have searched fruitlessly for scientific papers that even try to address this challenge. But the weakness in his stance is that at any moment, just such a paper might appear. Even in the few years since Behe threw down his gauntlet, many have appeared. Some, in fact, were published before his 1996 book. Neil Blackstone cites a few. Clotting, research argued in 1992, may have begun as a defense against bacterial toxins. Archaebacteria seem to have a prototype for the protein-degrading enzymes found in more advanced species. Hence, the antigen-presenting role of these molecules in the mammalian immune system clearly derives from such primitive functions. T cells cannot replicate without performing their immune system functions. So they may have a function not only in immune response, but also in regulating tissue growth. A telling instance comes from the study of hormones. Neither a hormone nor its receptor works without the other. So a mutation that allows production of a particular receptor would be useless without the matching hormone. And a hormone without its receptor would be like a telephone that no one could answer. Pressing the analogy, it's not just another phone that's needed, but phone lines, cell towers, switchboards, processing systems, a whole system. Recent findings, however, indicate that pre-existing structures were readily adapted to such roles. Joseph Thornton and his colleagues at the University of Oregon studied the receptors for steroid hormones in 59 species, including primitive jawless fish and skates. Calculating the point at which these types diverged on evolutionary assumptions, they synthesized a putative ancestral receptor that would bind with two distinct hormones. One of these two might have arisen by mutation and found a receptor ready-made, doing useful work already as the receptor for the other. So the new adaptation was not drawing to an inside straight. It was not a variant with no immediate adaptive value. Similarly, with the loblolly pine, tree trunks get their rigidity from lignins, complex polymers of linked monomer alcohols. One of these, appropriately enough called conifer alcohol, typically comprises 90% of the lignin. A specific enzyme forms it from the corresponding aldehyde. Now, a mutation can reduce the enzyme's efficacy by 99%, but the mutant trees, surprisingly, grow quite normally. They rely on another alcohol derived by a different biochemical pathway. Redundancy, as Niall Shanks and Carl Joplin argue, takes the sting out of the ID argument. A complex organic system need not be fragile and inflexible just because it's intricate. As Massimo Pigliucci explains, geneticists are continually showing that biochemical pathways are partly redundant. If a gene is adapted, one copy is free. If a gene is duplicated, one copy is freed from immediate constraints and can slowly diverge in structure from the original, eventually taking over new functions. This process leads to the formation of gene families, which is what we find, diversified for a variety of functions. The globins, for example, vary from proteins allowing muscle contraction to those involved in oxygen CO2 exchange in the blood. So mutations can knock down individual components of biochemical pathways without compromising the overall function. Redundant genes, then, open up possibilities for piecemeal evolutionary adaptation. Today's backup might well have been the default in ages gone by. The complex that impresses us now might not have been useless with missing parts. Besides, sexual reproduction may enhance the possibilities for coordination by pairing useful alleles with a mate's potentially complementary genes. Plainly, we don't know all that we might about past biochemical or developmental pathways, but we can hardly assume that the natural masterpieces we know did not emerge by tiny steps from cruder antecedents. Nature is filled, Kenneth Miller writes, with fully functional precursors to the flagellum, some functional enough to threaten human lives. The TTSS, type 2 secretion system, that highly virulent bacteria use to inject their toxins, is composed of proteins directly homologous to the proteins in the basal portion of the bacterial flagellum. As a counterweight to Behe's argument, Blackstone cites the electron transport chain, a membrane-bound series of redox carriers that transfers energies within the cell from catalyst to catalyst, flavoproteins, quinones, cytochromes, passing electrons sequentially from one carrier to the next and extruding protons that subsequently trigger the formation of ATP, the basic energy source of the cell. The marvelous precision of the structure, arguably the most widespread, complex, and critical biochemical mechanism known, he writes, might have made it the poster child of intelligent design, but Behe gave it short shrift, sidestepping the abundant literature concerning its evolution. And C.D. Deuves summed up the thinking on that score in 1995, well known before then Behe published his book, so Behe seems to have chosen his evidence to suit his case. In finding functional precursors for an emergent structure or process, Darwin himself set the pattern on the plane of general anatomy, arguing that in new adaptations, pre-existing structures and capabilities are utilized for new purposes, affording plenty of stepping stones for evolution. But we need not fill in every gap in current knowledge to expect that future research can do so. Behe plays up the gaps, but a reductio ad ignorantium is inherently inconclusive, boasting that its challenge will not be met, but not proving that what it asks for is impossible, or that relevant evidence will not be found, perhaps with the aid of new conceptual tools, just as elegant and novel as the Jacob-Monod model, the Watson-Crick model, was in explaining the genetic regulation of physiology and development. After all, when McCarty first proposed that DNA carries the data of heredity, most biologists thought its chemistry was too simple. They couldn't imagine how any substance less baroque than a protein was equal to the task. But as Helena Cronin writes, it's hard to reconstruct the steps it took to bake a cake, given only the cake. Yet that does not prove that baking is impossible. Spinoza seems to be the first philosopher to call out reductio ad ignorantium as a fallacy, although John Locke usually gets the credit. Making God's will the rival and antithesis of natural causes makes God, as Spinoza put it, the asylum of ignorance. When people turn to God only because their understanding has run dry, for lack of facts or adequate ideas, or just because the stakes are high, what they're relying on is a God of the gaps, a refuge of desperation, but otherwise dispensable. As Einstein warned in an address at Union Theological Seminary, where he spoke at the invitation of Louis Finkelstein, president of JTS, reliance on such a God, Einstein said, is not only unworthy but also fatal, for a doctrine which is able to maintain itself her doctrine which is able to maintain itself not in the clear light but only in the dark will of necessity lose its effect on mankind with incalculable harm to human progress. Then, harking back to Spinoza's linkage of religious obscurantism with intimidation and political usurpation, Einstein added, but in their struggle for the ethical good, teachers of religion must have the stature to give up that source of fear and hope which in the past placed such vast power in the hands of priests. The further the spiritual evolution of mankind advances, the more certain it seems to me, Einstein continued, that the path of genuine religiosity does not lie through the fear of life and the fear of death and blind faith, but through striving after rational knowledge. A God of the gaps will shrink inevitably. That's the end of the Einstein, this is me now. A God of the gaps will shrink inevitably as understanding grows. That's bad tactics for theists. It puts theism on the defensive. God cowers in the corners where light has not yet scattered the hobgoblins and retreats as knowledge advances. So God's dominion grows ever smaller. It's bad strategy, too, as well as bad tactics then, for the theist should see God in everything and not just where fear or ignorance takes hold. Spinoza's alternative is to see that when things pursue their own natures, they're not contravening but enacting God's will. God's plan is manifest in nature, not despite it. God acts not just in astounding displays of favor or violence, but everywhere and in all things. So science is not the enemy, but the ally of religion. The two are not set against each other as light against darkness, each calling the other by the uglier name. Science does not advance by displacing religion, and religion has no need of appeals to ignorance. What puts Einstein out of tune with the Maimonidean idea that God makes use of chance is the reductionistic treatment of chance and causal necessity along with it as rivals to theism. The specious assumption is that any adequate naturalistic account of a natural phenomenon obviates God's creative act and continuing governance. But that's just the response that reductio ad ignorantiam sets up. By viewing miracles as contraventions of nature instead of finding them within the work of nature, the reductio sets up its own defeat by challenging the naturalist to produce a natural explanation for natural phenomena or admit that their origins were supernatural, as if any natural phenomenon could be wrenched from its natural setting and still yield its natural effects or be made sense of scientifically. But there's another side to that story. For what prompts many a would-be theist to take refuge in intelligent design and the mystique of irreducible complexity is the specious claim that only naturalistic explanations are legitimate. The intelligent design movement is in no small measure a reaction to the hubris of the scientific claim that when we're out of mechanisms, we're out of truth. But on the contrary, it's just as much a fallacy to substitute proximate for ultimate causes as it is to proffer ultimates when proximate explanations are sought. If we want to know the ultimate source of all value, the beauty, truth, goodness, even existence of anything at all, mechanisms are not what we're after, and fobbing off the seeker with tales of subtle infracellular reactions is not a response. Philosophers like Daniel Dennett and biologists like Richard Dawkins say that there actually are no ultimates in the sense intended, that mechanisms are the only proper explanations. Dennett makes that very clear when he privileges mechanistic explanations as cranes and dismisses all ultimate appeals to wisdom beyond nature as skyhooks. Like any other affirmation or denial about ultimates, that's a metaphysical claim. It's not part of biology. It's not an implication of Darwin's work. It's actually a Darwinian heresy, one of many attempts to push or stretch the theory of evolution to yield implications far beyond its reach. Recognizing how Darwinism is commandeered in the service of scientism helps us locate the irritants that produce the intelligent design movement. Philip Johnson, an attorney and founder of the movement, addressing Dawkins directly, describes the adversaries' ID targets as dogmatic naturalists who rule out any idea that God might have a role to play in nature and preempt the very terms of discourse in which such questions might be discussed. He quotes Dawkins to the effect that all scientific evolutionists despise creationists, evidently taking them not to be sincere doubters, but dishonest propagandists, persons who probably only pretend to disbelieve what they must know in their hearts to be the truth of naturalistic evolution. That kind of polemic is not calculated to clear the air. When Behe sees reductionists leaning back in their Adirondack chairs and blowing smoke rings at the very idea of design, he takes a good swift kick at the two chair legs that still rest on the floor, aiming to disrupt their complacent posture by pointing to organic systems that seem in principle irreducible by any linear or additive gradualist account of the sort that an undirected evolutionary mechanism would seem to presuppose. Sheer chance, he is arguing, cannot account for life, since life is not a hodgepodge, not the sort of system that could be just thrown together, no matter how many random throws are allowed. Living organisms are not just complicated, they're irreducibly complex. Their parts are interdependent. Their subsystems could not in principle have arisen without purpose or design. The rhetoric of the reductio ad ignorantium is as old as God's challenge to Job from the storm wind, to tell, if he knew, how the mountain goats give birth, how the ravens are fed, how the hail arises. The real force in such questions lies not in there being no answer, but in the sense of wonder that they invite. Balbus, cast as a Stoic in Cicero's dialogue De Natura Deorum on the nature of the gods, urges that we are too familiar with the marvels that surround us and take them too much for granted to prize them. The sky would seem a splendid miracle had we never seen it. Perhaps we're jaded by familiarity. Knowing how refraction makes the sky blue, or how diffusion makes the sun shine, how fusion gives the energy to the sun, does not diminish the marvel, and curiosity about the natural causes of these events does not preclude but invites the appreciation that is at once a motive of scientific inquiry and a springboard of religious awe. Science, in that case, is not a rival, but a counterpart to spirituality, and the sense of the sublime that familiarity may dull, but art may reawaken, is a natural prelude, companion, and sequel to scientific inquiry and to religious awe. In my library, I pick up at random Carl Nicholas's book on evolutionary botany, and I read, "The terrestrial landscape is resplendent with examples of plant adaptations." Now I see why Nicholas used the word terrestrial. He opened his book observing that astronomers like to say we're fashioned from stardust, the source of all the elements. And Nicholas wants to add, as he puts it, it's also true that we're made from starlight, given the botanical source of life's energy. But why did he say resplendent? In linking the celestial and the terrestrial, he harks back to Galileo's and Newton's naturalizing of the cosmos, very much in the spirit of Philoponus. But he also seems not too eager for the starlight to fade. The light is natural, but still splendid. And when he says resplendent of the plant kingdom, that is the field of his life's work. And specifically of the adaptive achievements that are his cynosure, he allows himself a brief, joyful gasp of admiration, freed by his evolutionary theme of any fear that some critic might take his emotions to bear religious overtones. But they do. And so do Blackstone's words about the electron transfer and the discoveries that led to its comprehension. Religious awe is no mere failure of nerve, and the religious sense of mystery, as A.J. Heschel called it, is no mere failure of understanding. It's not dissolved by enlightenment. The distinction between mere ignorance and the sense of mystery that may ignite religious awe helps clarify Behe's ease with mechanism and its pairing with the celebratory tone so often found in apprehensions of natural glories. Behe's aim is to see the marks of wisdom in nature viewed as God's handiwork. But his self-image as the lonely champion taking the field against swaggering Philistines narrows his gaze and binds him to the weapons he expects to be most telling against his adversaries and most convincing to his onlookers. Etienne Gilson finds higher ground and broader vision by reflecting on Aristotle's thought that there's more beauty, more good, finer design in the works of nature than in those of art. As Aristotle tells his sometimes squeamish tyros in Dissection, if we value works of art for their virtuosity in representing nature, how much more should we marvel at the originals with their consummate absence of haphazard and conduciveness of everything to an end, as Aristotle put it, which in any living creature, he continues, is a form of the beautiful. Darwin stands not far off when he writes, "We see beautiful and curious adaptations everywhere in the organic world." Such remarks are telling, as Gilson writes, because they push the search for truth beyond the quest for utility that spirals down into the bathos of mechanism. But even utility bespeaks a larger good, and mechanism too holds beauty, despite the penchant of reductionists at times to slight its significance. Darwin's gift was to explain how living species pursue and enlarge their purposes. Like any biologist, he did not deny teleology, but presumed it in the idea of adaptation. But evolution detaches the idea of fitness from rigid, preordained norms and explains it by setting it in context, globally and historically. Natural selection shapes natural kinds, which are not archetypes, but populations, living, interacting with their environment. They have not just a form, but a history, and their telos is not the maintenance of identity. Rather, each type pursues survival in ways that hindsight can recognize as creative and projective of new and wider goals, including some that we humans hold most precious, like subjecthood and freedom. Design, I think, is an emergent property in living species. If life is not a throw of the dice, neither is it a preset script that would belie the open future and the very idea of freedom. But the imagery of sheer chance, so fondly embraced by mechanists from Democritus to Monod and Dawkins, is no more apt a description of evolution than Paley's watchmaker in the fumbling efforts that we all make to say something about God's work. It helps here, perhaps, to recall the Maimonidean thesis that chance itself is one of the ways in which God is encountered in the world. That thought was taken up in the work of Arthur Peacock, among others. But even as we acknowledge the role of chance, we must also remember that chance in nature inevitably has order as its counterpart. The more random a pattern is at one level, viewed in terms of one set of values, the more orderly it is at another. We see this in the elaborate apparatus needed to generate random numbers, and again in the kinetic law of gases. But nowhere is the complementarity of chance and order more manifest than in the genetic lottery. For Lamarck was wrong. Variants in the first instance do arise at random with respect to an organism's needs, but the chromosomes preserve the benefits of past trials, and their structures allow the system continuously to test or grope, as Teilhard put it, for new combinations, not relying on point mutations, mere single base substitutions. Sexual reproduction, meiosis, meiotic drive, crossing over, and recombination continually reshuffle the deck without shredding the cards. Even the brief lifespan and rapid reproductive cycles of some systems turn over, found in bacteria and in a different scale in many insects, allow rapid generational response to a changeable environment. So life does take chances, but there's more to evolution than sheer chance. The Hardy-Weinberg equilibrium is a theoretical ideal, but in real life, it's a limiting condition. Living species do not mate utterly at random. Gene flow and mutation do happen. Populations need not be large, and selection pressures are never absent or even static. So in the world of living organisms, genes make opportunities. Dice cannot. They cannot do the ongoing work of evolution because dice can't make a path for themselves. But that's the task faced by every living being. God is not Rube Goldberg, starting with an end in view and then building some elaborate contraption toward that end. Eternity does not march temporally from niche to niche, as evolution does, or work back from ends to means, as human plans may do. In God, the Alpha and the Omega, the end, as the Hebrew poet puts it, was implicit from the outset. Sof ma'aseh b'machshava techila. And yet, still needing to be instantiated. How eternity expresses itself in a temporal, evolutionary world is a question we're better equipped to answer than we are to address the eternal thoughts of a timeless being. If time, as Plato put it, is the moving image of eternity, time at least is where we live. Its game is the kind we can learn to follow, as we do in the sciences. So it isn't only Einstein or Newton who glimpsed God's mind. Darwin did so as well. So did Mendel, and every naturalist who sees the sense in nature, discovering God's idea, not unborn within God's mind, but working itself out in the world we know. A human inquirer, Maimonides writes, can learn how a clock works by dismantling it. A human inventor can design a clock, assembling it, first mentally as a notional, temporal construct, and then physically in a prototype. But when God makes living creatures, much of the work is left to them in their pursuit of life. Small wonder that Spinoza spoke of the conatus, the striving that he saw as the essence of all things, their general tendency to persevere, witnessed even in the impenetrability of matter and the inertia of moving bodies. To understand creation, given what we know today, what we should say is what we see, that God gives beings an impetus to persist. In the case of living species, This is a good that their own strengths will aid them in securing and will lead them to define more fully as their kinds evolve. Each being is set into an environment where it seeks its good, a good in some measure to be realized, but never guaranteed, since the surround is thick with the projects of other beings, each reaching for its own good in its own way.